Good afternoon, everyone. How are we doing? Our changing city, transforming climate data into community connection. Thanks for coming to our talk today. Just a quick overview. Our changing city was a physical installation we built after we won some funding from the Bloomberg Global Mayoral Challenge in 2022. And the project goal was to create an innovative digital experience to help Wellingtonians understand localised impacts of climate change and the adaptation options available. So who are we? I'm Jeff Jones, technical lead for the digital innovation team at the Wellington City Council. So digital innovation team, they explore emerging technologies like game engines, 3D visualizations, interactive media and AI solutions to help solve real world city challenges. So we work to embed innovation capabilities across the organisation, and we're trying to constantly improve and address the challenges that the city is facing, whether that's through climate information, urban planning, or city services. A key part of our team's role over the last 3 years has been building and maintaining Wellington's digital twin, which, as I said, was originally started from that initial award from Bloomberg.
Hey everyone, my name's Louis Criswell. I am a senior Unreal software engineer at Prismatic Studios. We're an Unreal Engine technical consultancy and co-development studio based in Auckland. We also work closely with Epic Games as an Unreal Engine Gold service partner, and we partnered with Wellington City Council for this project to help tackle some of the more complex challenges in it.
So I thought I'd just start with a quote from a local after they played through the experience, and they pretty much said they had no idea that Miramar used to be underwater and also was a lake at one point. Climate data can feel really complex and abstract, and the goal of this was to make it really understandable. Yeah, so our job, making it understandable and real for Wellington.
Yeah, Wellington faces many challenges in the foreseeable future when it comes to climate change. Increased risks from storm surges and landslides to the complications issued by sea level rise. These issues will affect all Wellingtonians to varying degrees. However, the specifics of the threats and the solutions that they could help employ are harder to understand than just a vague foreboding warning on the evening news. This is because climate change data is usually collected in complex, abstract spreadsheets and reports that are difficult for your average person to digest in a reasonable amount of time. What we wanted to achieve with this project is to present this data to the public in a more engaging and more familiar context.
Yeah, so before I go over the next 2 points, we made a little video that you could optionally watch at the start of the experience, and I think it does a really good job of sort of summing up the context and onboarding you onto this. So we'll just give it a watch. It's only about 40 seconds.
We're in a dynamic landscape, tūpoko tika Māui.
Climate change will mean we need to change the way we look at things.
I have noticed different changes in the weather.
The flooding and the landslips.
The sea levels.
What can we do now to prepare ourselves for that?
Can we learn from Mātauranga Māori?
To adapt to climate change.
For the future, for our mokopuna, for our taiao.
It's about how we live with nature.
And look after each other.
Yeah, so as you can see, giving communities that shared understanding of climate change is really important, allowing them to understand what it means in their local community and not just reading about it within reports. How can we expect communities to make informed decisions on solutions if they don't really understand what the impacts or the future look like? We also knew that from the beginning we really wanted to weave Mātauranga Māori throughout this project. It wasn't just about presenting Western climate science, it was about bringing together different ways of understanding and environmental change, and Indigenous knowledge systems have been observing and adapting to environmental shifts for centuries. And so that perspective was really important for us. So, the vision, what did we want to do? Well, Smart Council and our climate change response team joined forces to secure that Bloomberg Global Mayoral's Challenge Award. And the goal was to further develop an innovative digital community engagement tool to raise awareness about localised impacts and explore ways to prepare for climate disruption in the years ahead. We wanted it to be more than just an information tool. We really wanted to create powerful, immersive experiences that help communities see, help them understand, and help them engage with climate content in a way that gave them a better understanding. We weren't just presenting data, we were trying to craft experiences and stories that could shift the way people think about their relationship with the environment. We really wanted to make sure that these impacts they were seeing were localised, they were relevant, and they could understand what climate change was going to mean for them. To do that, we had to bring a lot of different teams from a lot of different perspectives together. It was a really diverse team that made this. So the climate change team were our head chefs. They were sort of spearheading the direction and the way we wanted to roll out this tool. But we also worked closely with NIWA, with Wellington Water, and our own internal GIS team to ensure the data we were showing was not just compelling, but it was accurate. You know, scientific integrity here was a non-negotiable. The project touched on lots of different disciplines and perspectives, but because we were also looking back into the past and understanding how we used to work with the land and the cultural stories surrounding Wellington, we brought in a cultural advisor, Hannah Buchanan from Taranaki Whānui, to help guide us through that process and to help bring those stories in. And that was a really awesome experience to be a part of. We also collaborated with Wellington City staff to understand the current issues and also community groups to understand their perspectives. To bring all of those people together, we had an awesome content writer called Nick Jarvie-Waldrum. She helped bring those different perspectives together and actually craft these narratives and craft these stories, looking at different impacts. We looked at flooding, we looked at landslides, and we looked at coastal inundation. So on the council side, we had quite a small tech team. It was myself as the developer. We also had a designer and 2 3D artists. And that's really where Prismatic came to the table to help give us the technical expertise we needed.
Yeah, on the Prismatic side of things, our expertise definitely lies more in the software engineering side of development. So systems and tools programmers were a necessary requirement for this work. However, we also had a little bit of tech art and 3D modeling work to do on this project. Now let's get into how we did it.
Love that GIF. So the technical foundation. The digital twin forms the foundation for all of the stories and narratives that take place within our changing cities. And how did we build it? Well, it's built from aerial photography and digital elevation maps. Those were processed in a program called ArcGIS. We then brought those into another program called City Engine, where we were able to create terrain tiles and then batch export them out and import them into Unreal using Datasmith. That gave us our terrain and our landscape, but on top of that, we also had planes that flew over the city and scanned the buildings using photogrammetry and then reconstructing those as 3D meshes. Now that we've got our terrain and our buildings, we put in some weather systems, some water systems, and you've got the digital twin. And this is the place where all of our narratives and our stories can take place. As I said, understanding the past was really, really crucial, and a big part of that is land. Land is always changing, and it was one of the fundamental truths we wanted to people to grasp. We wanted people to be able to interact with the landscape and change it in real time to increase engagement and immersion. So we built a system that allows for interactive terrain changing. People could literally watch the landscape terrain transform beneath their eyes. We were able to show land reclamation, land cutting, but also natural events that have shaped the Wellington we know today. I think, maybe not surprisingly, people's favourite part of the experience was making the Horowhenua earthquake happen, which drastically changed the area around Miramar, Lyell Bay, Evans Bay. And that kind of goes back to that initial quote at the start of the talk. You know, people just didn't realise that that used to be underwater. And because of that, it's really shaped the impacts that that area faces today.
On the technical side of things, getting the terrain morphing effect to work required careful optimization, as it can be an expensive operation, especially due to the scale of our world and the size of the landscape tiles. For this, we would swap out our much more optimized nanite terrain tiles for static meshes that we could control through non-VT vector displacement maps, which can be expensive when it comes to memory, but once the blend is complete, we could swap them back to the nanite tiles that have been switched to match the end of the morph, making the potential performance hit only a temporary one during the blend.
To continue building understanding, we were able to use a contextual media system where we could embed photos and videos from the past directly into the 3D landscape. So we were able to weave in those cultural stories about how we used to work with the land and also the early past sites that existed in these areas. We integrated in historical maps right into the terrain. So when you're looking at a particular area, relevant historical context appears. We're also able to show, for example, here, when forests were burnt down and the lake was drained, we brought in some historical photographs from that era. Another thing we were able to do is embed videos into the experience to help explain complex processes like dry day flooding, to really help people understand the processes of climate change rather than just talking to them about it. They can actually see it happening, understand it, all within the context of the experience. Another thing we allowed for was more of an immersive type of experience where you could actually fly down to the landscape and take control of the camera yourself. And that's what this bit here shows.
So Wellington City Council holds a lot of climate change data that would be great to share with the public. A lot of this data is stored using ArcGIS, which is a geographic information system used industry-wide by governments and businesses for map data visualization. Most importantly, it is used extensively by the council. Building a pipeline to include that data in the project was a crucial step. And ArcGIS is a dense tool that requires a lot of knowledge to understand and to operate. It's not something the average developer or user in our project could understand. Which is where we came in. We created a GeoJSON data importer as a plugin for the project. Using this plugin, we can import different types of data into the project for visualization. Point data would allow us to show locations of interest, such as schools or hospitals in problem areas that could be affected by climate change in the future. With line data, we could visualize pipe networks or roads and what parts are within at-risk areas. The last type is polygonal data, which would allow us to map out areas or danger zones that include probabilistic flood data and erosion data. The point and line data were relatively easy to import and display in the DCM using world-space widgets or spline meshes respectively. The polygonal data was the most utilized type, but it also brought the most challenges. With some simple data sets, we could utilize code in Epic Games' geometry script module to create static meshes that we could display in the world. However, for more complex data sets that contain non-standard polygons, such as the ones you see here, we needed to write our own custom monotone decomposition implementation to handle the triangulation before we constructed the meshes. This was a really valuable tool to work on, and we've continued to develop it with the council, making it both editor and runtime capacity, along with customizable import settings based on metadata within the GeoJSON datasets.
Yeah, narrative was a really important part of our changing city. We really wanted to be able to craft and tell stories in a clear and easy to understand way. And so we knew we needed to be able to synchronize events and craft smooth transitions and intros to really maximize impacts. For example, when moving to an area, if we wanted to go back in time or trigger a weather event to happen or have the camera swoop past a certain area, we wanted to be able to design this. So we leveraged Unreal's level sequencer, and this allowed our designers and artists to jump into it and design it at editor time. And then they could craft those camera transitions without needing to necessarily understand the technical complexity under the hood or even having to play through the whole experience. They could just open up the level sequence asset they wanted, make the changes, save it, and then at runtime, we were able to leverage the binding overrides to swap out the player camera and any other dynamic elements and actually bind it to that level sequence so that we could have a smooth transition. We didn't want there to be a hard cut, so we ended up using, rather than absolute variables for things like field of view, depth of field, transforms, we had those as targets that our dynamic bindable camera would be bound to and used it as a target.
To control the flow of the experience, we used state machines that would allow or deny movement between different points of the experience based on user input or triggered events. We also had a central subsystem that would trigger or broadcast these events to other actors in the system. And all of the systems that we've talked about so far and the actors within them utilize the subsystem by listening to those events and then changing the state of their own internal code based on these changes. For our implementation, we used a third-party plugin named Logic Driver, which is an extension of machines much closer to behavior trees in terms of layout and design. We went with this approach for a few reasons. One, for its ease of use, especially when bringing on new developers onto the project, or when we want designers to make some changes without needing to get into the source code. It's also very useful for visually representing the UI flow of our game. As you can see here, we have a node representing each state in the project, sometimes representing a whole other state tree. This is great for debugging the flow of the game and quickly making changes to where and when a user can progress. For these nodes and the transitions between them, we wrote custom implementations that allow us to define all the settings that we might want to change when we transition from one state to another. These settings include audio, both ambient and background, camera transitions and cinematic sequences, new text and images that would populate our modular UI, chronological changes such as day and night cycles, but also different historical time periods that would be utilized by the terrain morph tool. Finally, we can also control our weather systems, which, given the nature of the project, is crucial.
Yeah, and one thing I'll add as well is the system leveraged gameplay tags pretty extensively in using the sort of nested behavior of gameplay tags to give us a final discrete state. And that was really, really useful, those two things working together.
As a part of receiving the grant for this project, we were required to provide Bloomberg with usage metrics once the experience was out on display in the public. Wellington City Council has an existing pipeline for handling this data, which was already being utilized by the accompanying website to this project. On the Unreal Engine side, we built a simple plugin that would utilize Google Analytics 4 to track events across the experience. This tied in very nicely with our state machine system and allowed us to track practically every single button press or state change in the experience. That was a bit excessive for our purposes though, so we cut it down to some key events. The important events we did keep track of include starting or ending the experience, moving to a whole significant area of the experience, or engaging with a piece of media. Besides being a requirement, there were other benefits to the system, such as information leading to bugs within the project. For the first couple of days after the debut of the physical installation at Te Papa, we had a base user count that roughly lined up with what we expected. As you can see here though, the next day we had a huge spike in events for people who had started the experience. This helped us to find an issue where if you quickly restarted the experience over and over, it caused the intro music to play many, many times, layered over top of itself, very loudly and discordantly. Apparently a school field trip had a lot of fun with that one. But it helped us to diagnose, fix the issue, and quickly get a new build out onto the site.
Yeah, when we got told about that, I had in my head, just the heaps of kids almost listening to EDM or something by hitting this button constantly. Yeah. So what did we actually end up building? We ended up building a large physical touchscreen display that was embedded into sort of a plywood panel that was just one of three. It was set up like a museum-style installation, and it was really awesome. But through its deployment, we faced quite a lot of challenges relating to the physical aspects, and that taught us some really valuable lessons. Heat became a major issue. At one point, parts were literally melting in one of the computers. We had a spare, so we put that in. But after that, we had to implement additional fans and also made optimizations for a lower intensity welcome screen, so it didn't have all of the terrain and buildings loaded behind the UI. But we also created a timeout and out of hours sleep option. While that was happening, we were also doing kiosk mode, Windows kiosk mode. That presented its own challenges within the council as we were essentially setting up a new deliverable. And so we had to work through some security concerns and operational requirements with the IT team. And we eventually got there and they were actually able to automate all of the sleep and all of that stuff. But it was definitely something I wish we had started earlier. Really, really helpful command that we implemented into the executable file itself was just the -unattended flag. It meant that if there was ever a crash that happened, the application would just automatically restart rather than the little window that pops up that says you've got a crash and a human having to interact with it. It would just automatically restart and we could receive that event through the metrics. Network access was another huge hurdle. the tech team at the City Council told us we would only have Wi-Fi available within our WCC networks, so libraries, sports centres and so forth. So we had to develop an offline analytics system that we ended up saving metrics to a JSON file and then had a custom script that ran to collate and report those metrics, so we were able to get metric data without being constantly connected. We also designed things for things like screen burn, so we had a dynamic looping title that just helped preserve the hardware's display over its life. And what we learned. So we discovered that different locations attracted different demographics. Libraries brought us older residents and families looking to explore educational experiences. Sports centres attracted a younger audience, and the installation worked really well for school trips and community events. It also kind of lined up with what the council was thinking, and that this tool is something that the climate change team want to leverage further in community events and use it as a place for starting discussions and create conversations with the community. What shifted? People began seeing their neighbourhoods differently after using the tool. Climate risks definitely felt more real and immediate when people could see it happening in their own communities under different scenarios. Visitors constantly left feeling curious about what they could do next, although we learned that action or next steps weren't always clear to them. And that's actually a really hard thing about climate change, is trying to express what we can do next. We learned that tangible beats abstract every time. When people can touch, manipulate, and see changes happen in real time, understanding follows. Collaboration builds trust. You know, firstly, in the design of this experience, it was a very collaboratively designed experience. We built trust there, but we also built trust in collaborating with the community when we roll it out to those different places where it's in use. And finally, curiosity is a powerful starting point, but action does need guidance. It's not enough to make people care. We need to show them the concrete steps that they can take. And as I said before, that is really easier said than done. And we gave it a starting point here with showing a lot of adaptation options, but it's something that we want to continually work on. Thank you. And that was our talk. Any questions? Yeah. Yeah.
Quite a long time.
Yeah, so that about a year and a half. Yeah. Yeah, to make our changing city, yeah.
But then there was also all the work that had to go into the DCM before that as well.
That's right, yeah. There's probably about a year before that of working through preparing and getting that data that actually went into building the twin, yeah. So it was a 3-year grant, and it started in 2022. Yeah. Oh, yeah.
Hey, I was just wondering if there's anywhere we can look at and interact with just a digital twin even.
Yeah, it's something that we are looking at wrapping up into just a shareable thing that we're going to put on Git, which will just be sort of the base digital twin, just have the terrain in there with the buildings and maybe some very simple scripts for importing the GeoJSON data. But we're not quite there yet, but yeah, it's something that we are looking at.
Cool. Where should I keep an eye on for news about that if it happens?
I think the council website would be the best place.
Cool.
Yeah.
Thank you.
Yeah. We've got one down here too.
Hi. So I was wondering if during this project, was there anything that you, like, for time constraints or anything like that you're like, oh, we would have loved to have done this, but we had to cut it, we had to let it go, and what was that, and what was the reason, if there was one?
Yeah, I've definitely got one.
Yeah, I can think of one, but it's more of a technical one. I'd love to go back and rework the entire state machine system with the knowledge that I have now. There's definitely a much better way I could have set that up, like have everything paying attention to it and building itself off of that rather than just populating or pretty much. What was your...
Yeah, and my one was that I would love to have explored more of those immersive experiences where you actually went down rather than... So our team was obviously constrained within the technical capability, both with working with Unreal, but also some of the 3D content. So we leveraged a lot of rendered videos that we put into the tool, and then we had a few experiences where you're actually able to sort of dive down and control the system. Obviously, the whole tool itself was interactive, but some of those like contextual explainers would have been great to have being more immersive and interactive. Yeah.
Cool. Thank you.
Thank you. I'd love to hear more about the digital twin. Was that something that you built specifically for this, or was that a pre-existing thing? And I guess you kind of touched on how it was built, but was there any more like specifics or technical things about that you learned or were, interesting for you?
Yeah. It was built for this. It was part of the grant and was kind of, the council already does a lot of data collection in terms of like flying over. So it was just kind of tacked on to those already existing. So when we were collecting the building data, for example, they were doing the flyovers to capture the property boundaries and stuff. They just put extra cameras on those planes. The aerials and the terrains, I mean, they were processed in ArcGIS and then also, brought into City Engine and was created there. There was a big sort of batching script we wrote, but actually with the input data being sort of processed and formatted for us, it was actually quite simple just to run it. It was just the amount we had to deal with. We sort of had about 50 terrain tiles that covered all of Wellington, and then we had maybe about 16 large data tiles that were like for the surrounding areas, going up to Whenua, Mata, and Upper Hutt. Yeah. Hopefully
Awesome.
that answers it. But come and talk to me after. I'd love
cool.
to chat
Thank you.
more. Yeah.
Hey there. I was wondering if this is going to be open to the public, like the experience. Is this going to be in the library, or is there any way we could actually interact with it?
Yeah, definitely. It's continually being rolled out still, both within the libraries. I don't know the exact schedule of it. I potentially could try and find that after this talk and share it with you. But yeah, no, it's definitely still in use. And it is one of the limiting factors of it, that it is a physical installation that we built. There was a website where we took a lot of the content and put it in there. But yeah, just like you have to actually find where the thing is to experience it, and it is a bit challenging. Yeah.
Thank you.
Awesome. I think we'll leave it there. Thanks for coming. Cheers.
Thank you, everyone.